Hello everyone. In this lecture, we'll study the homogeneous differential equations. Before starting with the homogeneous differential equations, we will first understand what are the homogeneous functions. Okay, homogeneous functions. So, what are the homogeneous functions? Consider a function, let us say f of x comma y, which is a function of x and y, given by x square plus xy plus y square. So it is a function in both x and y. If you look at the power of the first term, it is 2. Okay. If you look at the power of last term, it is 2. But the power of second term is 1 and 1. But the sum is 2. But the sum is 2. So there is a homogeneity in the powers of the terms. Such a function is called as a homogeneous function. Such a function is called as the homo. What is a homogeneous function then? A homogeneous function is a function in which the sum of the powers of each term is same. Another example, if I consider, let's say f of x comma y is equal to, if I take, let's say, x square plus 2x plus 1. Okay, here the power of the variable is 2, here the power is 1, here the x raised to 0, so there is no homogeneity, so therefore it is not a homogeneous function. It is not a homogeneous function. Okay, if I take the properties of these two functions, and if I have to make a standard method to verify the given function is homogeneous or not, ಹೇಗೆ ಚೆಕ್ ಮಾಡ್ಬೋದು ಅಂತ ಹೇಳಿದ್ರೆ, what we will usually do is, in the first step we substitute x equal to lambda x. In the place of x we substitute lambda x, and in the place of y we substitute lambda y. Okay, so x ಇದ್ದಲ್ಲಿ lambda x, y ಇದ್ದಲ್ಲಿ lambda y ಹಾಕ್ತೀವಿ. Then if f of lambda x comma lambda y ಅಂದ್ರೆ ಈ ಫಂಕ್ಷನ್ ಅಲ್ಲಿ, ಓಕೆ, ನಾನು ಲ್ಯಾಂಬ್ಡಾ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದೆ, ಎಕ್ಸ್ ಇದ್ದಲ್ಲಿ ಲ್ಯಾಂಬ್ಡಾ ಎಕ್ಸ್, ವೈ ಇದ್ದಲ್ಲಿ ಲ್ಯಾಂಬ್ಡಾ ಎಕ್ಸ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದೆ ಅಂದ್ರೆ, if f of lambda x comma lambda y is lambda raised to n times f of x comma y, ಅಂದ್ರೆ ಲ್ಯಾಂಬ್ಡಾ ಸಮ್ ಪವರ್ ರೇಸ್ ಆಗಿ ಹೊರಗೆ ಬಂದು ಮಿಕ್ಕಿದ ಫಂಕ್ಷನ್ ಹಾಗೆ ಉಳಿದ್ರೆ, then we say that this is a homogeneous function of degree n. We call it as a homogeneous function of degree n. Okay, if I take the first example itself, f of x comma y, f of x comma y is equal to x square plus xy plus y square. Okay, if I take this one, then if I replace x by lambda x and y by lambda y, what will I get? I will get lambda square x square plus lambda x lambda y plus lambda square y square. So lambda square will come out. I will get what? Lambda square is common, right? Here lambda into lambda is lambda square, right? So if I take out lambda square, I'll get x square plus xy plus y square. So this will give you what? Lambda square times, what is x square plus x square plus y square? F of x comma y. So here you can see f of lambda x comma lambda y is equal to lambda square times f of x comma y. Therefore f of x comma y is a homogeneous function of degree 2, because lambda square bandide. Looking at this, we say that it is of degree 2. Okay, if I consider one more example, let us say f of x comma y is equal to, consider the example 1 and this is example 2. F of x comma y is equal to, let's say, x plus y divided by x minus y. Okay, if I take this example, or if I make it x cube plus y cube divided by x cube minus y cube, anything is fine. Okay, so if I replace x by lambda x and y by lambda y, what will I get? It will be lambda cube x cube plus lambda cube y cube, right? And then lambda cube x cube minus lambda cube y cube. Okay, so this will give you, if I take out lambda cube, I'll get x cube plus y cube If I take out lambda cube in the denominator, I'll get again x cube minus y cube. Okay, this lambda cube and lambda cube gets cancelled. Look, lambda cube by lambda cube, if they get cancelled, I'll get 1. But I can write 1 as lambda raised to 0, right? So therefore I can write this down as lambda raised to 0 times x cube plus y cube by x cube minus y cube will give me f of x comma y. Okay, so f of lambda x comma lambda y can be written as lambda raised to 0 times f of x comma y. So therefore f of x comma y is a homogeneous function of degree 0. It is a homogeneous function of degree 0. Okay, so this is how we can check whether the given function is a homogeneous function or not. Okay, now there is an important property of a homogeneous function. Okay, what is it? Any homogeneous function, I will just write it down as a note. Okay, any homogeneous function of degree 0 can be expressed as a function of y by x or x by y. It is a very important property that we will be using. Okay, what is the property? Any homogeneous function f of x comma y of degree 0. Okay, ನೀವು ಯಾವುದೇ homogeneous function of degree 0 ತಗೊಂಡ್ರೆ ಅದರಲ್ಲಿ ನೀವು you can entirely express that as a function of y by x. ಅಂದ್ರೆ x separate, y separate, ಆಮೇಲೆ ಬೇರೆ ಯಾವುದೋ ಟರ್ಮ್ separate ಈ ತರ ಬಂದಿರೋದಿಲ್ಲ. ಅಂದ್ರೆ ಎಲ್ಲ ಟರ್ಮ್ either y by x ಇಲ್ಲ x by y ಇರುತ್ತೆ ಇಲ್ಲ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. Okay, so if I take this example, let us say the second example. What is the second example? The second example is f of x comma y is equal to x cube plus y cube divided by x cube minus y cube. Okay, if I divide every term by, let's say, x cube by x cube will be 1 plus y cube by x cube will be y by x whole cube, right? Divided by x cube is 1 and then this will be y by x whole cube. Just see how easy it is, right? So therefore this is what we have. Okay, this is a function of y by x, and once we get this, we can also express this as a function of x by y. How? If I divide every term by y cube, what will I get? 1 x cube by y cube is x by y whole cube. Okay, plus y cube by y cube is equal to 1 divided by x cube by y cube is x by y whole cube minus y cube by y cube is also equal to 1. So therefore f of x by x comma y is equal to x by y whole cube plus 1 divided by x by y whole cube minus 1. So like this. How did I convert this as a function of y by x? Dividing it by highest powered term of y, term of x here. Similarly dividing it with the highest powered term of y. Okay, in this case. So this is one important property that we have to remember. Any homogeneous function of degree 0 can be expressed either as a function of y by x or as a function of x by y. Okay, so this is all about the homogeneous functions. Now to define a homogeneous differential equation. Okay, homogeneous differential equation. I will now define a homogeneous differential equation. Okay, a differential equation dy by dx is equal to f of x comma y. Any differential equation of this form is called as a homogeneous differential equation when f of x comma y is a homogeneous function of degree 0. If f of x comma y is a homogeneous function of degree 0. Okay, dy by dx equal to f of x comma y. Any differential equation of this form is called as a homogeneous differential equation when f of x comma y is a homogeneous function of degree 0. Okay. Now, how will you solve it? How to solve this? Okay, how to solve it? Now, we know that f of x comma y is a homogeneous function of degree 0, right? ಇಲ್ಲಿ ನಾವು ನೋಟಲ್ಲಿ ನೋಡಿದ್ದೀವಿ any homogeneous function of degree 0 can be expressed as a function of y by x. Okay, so what do we do is, if we have dy by dx is equal to f of x comma y, definitely this f of x comma y can be expressed as a function of y by x, some function of y by x, let's say g of y by x. Okay, so what we will do is, we will first express this as a function of y by x. Okay, and then, so we will write it down. What is our step 1? The step 1 is express the function f of x comma y as a function of y by x, that is some g of y by x. Okay, in step 2 what do we do? In step 2 what do we do is, we substitute y by x equal to v. So what will we get? We will get y is equal to xv. If we differentiate it, what will I get? I will get dy by dx is equal to, derivative of x is 1, keep v as it is, plus x as it is, derivative of v is dv by dx. Okay, so therefore what will be our differential equation now? So in step 3, on the left hand side we had dy by dx. What is dy by dx here? Dy by dx here is v plus x dv by dx is equal to, on the right hand side we have f of x comma y. Now we have written it as g of y by x, so I will write it as g of y by x is v. Okay, now this differential equation is a variable separable differential equation. This differential equation is a variable separable differential equations. All v terms towards one side, okay, and all x terms towards the other side, and then we integrate it with respect to v, and this one we will integrate with respect to x. Don't don't get confused. This is not just v. I am saying all the v terms, and here we are saying all the x terms. Okay, so now we have a differential equation which we can solve by separating out v and x terms, okay, as a variable separable differential equation. Okay, so this is how we solve it. In the next lecture what we will do is, we will take up a few examples on homogeneous differential equation, and then we will see how to solve. Okay, we will take up one example of general solution and one particular solution, and I'll teach you how exactly you can solve a homogeneous differential.